Welcome, folks. I want to give an intuitive introduction to isomorphisms before we get into the precise definition. So, roughly speaking, two groups are isomorphic if they have the same structure, and two groups might be of the same size, but not isomorphic if they have different structures. So, whenever two groups are isomorphic, they necessarily have the same size, but just because two groups have the same size does not mean they're isomorphic. There are exactly two different types or isomorphism classes of groups of size 4, okay? And the most common names for those two types are Z mod 4Z, it's the integers 0 up through 3, and then you add them mod 4 to get this multiplication table. And then the other group is the Klein 4 group. It's often denoted Z mod 2Z direct sum or times another copy of itself, Z mod 2Z. And what this means is ordered pairs of elements from Z mod 2Z, which are 0 or 1. And then how do you combine two ordered pairs? Let's combine this ordered pair with this ordered pair. Well, you just add the elements in Z mod 2Z. So first we add 0 and 1 to get 1 in Z mod 2Z. And then we add 1 and 1 to get 2 or 0 in Z mod 2Z. So these are the two different isomorphism classes for groups of size 4. Any group of size 4, it has the same exact structure as one of these two. I think of Z mod 4Z as having this diagonal structure in its multiplication table, whereas the Klein 4 group has this crisscross structure in its multiplication table. Okay. One group that has the same isomorphism type as Z mod 4Z is the rotations of the square. So there are 4 ways you could rotate the square and map it back to itself. You could rotate by 0, 90, 180, or 270 degrees. And when you do these rotations, if you multiply them out, you know, a rotation by 90 degrees followed by another 90-degree rotation gives you a 180-degree rotation. If you multiply these out, you find the same diagonal banded structure. And that's not the precise reason, but that's a good intuitive reason why this is the same group up to isomorphism as Z mod 4Z. Let me end this video just by giving you one other group that has the same isomorphism type as the Klein 4 group. So we haven't talked much about this yet, but the group will be U8, which is all the numbers from 1 up to 7 that are relatively prime to 8. And the operation will be multiplication mod 8. So we'll just fill out the multiplication table together and see how it recovers the same crisscross structure as the Klein 4 group. So what are the numbers from 1 up to 8 that are relatively prime to 8? Well, 1 has no common divisors with 8. 3 also has no common divisors with 8. 5 has no common divisors with 8. And 7 has no common divisors with 8. The operation is multiplication. So when I multiply 1 by 1, I just get 3. I just get 1. 1 times 3 is 3. 1 times 5 is 5. And 1 times 7 is 7. What is 3 times 3? 3 times 3 is 9, but mod 8, that's 1. What is 3 times 5? That's 15, but mod 8, that's 7. And 3 times 7 is 21, Mod 8, that's 5. That's 5 more than 16. And then what is 5 times 5? That's 25. But mod 8, that's 1, because 25 is 1 more than 24. 5 times 7 is 35, which is 3 more than 32. So mod 8, that's 3. And 7 times 7 is 49, which is 1 more than 48. So mod 8, that's 1. So you see we do get this crisscross structure present in the Klein 4 group. So this is one of many different example groups that really turns out to be the same as the Klein 4 group. So let me end there. That's just an intuitive introduction to isomorphisms between groups. The top 2 groups are isomorphic. The bottom 2 groups are isomorphic. But neither of the top groups are isomorphic to either of the bottom groups. And we'll give you the precise definition in the next video. Any public questions? All right. Thanks, folks.